Year 12, we're still in lockdown. What's going on? How many weeks is this? This lesson is a bit tricky because it pulls lots of things together. You've got to get lots of ideas together, but there's nothing really new in it. The only thing that's new, I suppose, is efficiency, which isn't, you've seen it in year 11, but maybe new to you. So you've got to remember that efficiency equals useful energy out over total energy in. Okay, that's really it. Now, what they'll do is they'll give you some questions that link into renewable energy and how energy calculations can be linked in to real life. Okay, looks a bit blurred, that, doesn't it? Why is that? Don't know. Let's go for this one here. Okay, it is on page 179 of your textbook, but it's quite hard to follow. And I've seen this sort of question a lot of times. What it's doing is it's linking power. It's linking per second with a quantity, so it could be electrons per second, as in current. It could be energy per second. Okay, in this case, it's air per second flowing. So it's a wind turbine question. Let's just go through it. All right, so we need to sort of have an equation that links energy to the wind speed and the density of the wind. Okay, for a wind turbine. All right, so a wind turbine, obviously you've got your wind turbine there, happily whizzing round. We've got to remember that there is a cylinder of air going through that every second. So this cylinder of air is moving along there. The cylinder will have the same area as the area cut by the blades of the wind turbine. We'll call that capital A. It'll have a volume of capital V, and the length here, well, obviously speed is distance over time. So distance, S equals VT. Little v for velocity, big V for volume, note. Okay, so we've got SA would give you the total volume of air there. Okay, so the total volume of air is SA. Volume equals SA. But the volume per second second is going to equal to that per second, okay, speed per second, distance per second. So that will equal, if we look at it, that will equal VA, okay? I think that's the hardest bit in the question, getting from there to there. Volume, so in other words, distance per second times area. All right, distance per second times area. So that's giving you volume per second. Okay, so we've got volume per second now is equal to VA. All right. Now, kinetic energy, one of those things you've got to remember is half mv squared. It is given, but you'd need to remember it for all practical reasons. Half mv squared, okay? Now, we're not given the mass, but we are given the density, okay? And we're given the area, and we're given everything else like that. Okay, so we need to get rid of mass because we don't know mass. Okay, now how can we do that? That's a good question. Okay, well, mass equals, if we go to density, so density, that's rho for density, equals mass per volume, capital V, then we know that mass, by rearranging that, mass equals rho V. Okay, so we can straight away go rho big V, V squared. Okay, that's what kinetic energy equals. We've got that far. All right, now rho V, that's not P, that's rho V, okay, is equal to the mass. So we can look at trying to get rid of this V, because we don't know V, but we know the velocity. All right, so we've got rho there, and we need to get rid of V. Okay, so V equals, what does V equal? Well, we looked at V before, volume per second. If we look at the kinetic energy per second, okay, well, we know here that the volume per second now, because we're moving from there, we were kinetic energy, now we're kinetic energy per second, which is power, kinetic energy per second, equals this. Okay, volume per second equals little VA, so we're going to replace that volume there, okay, with little VA, velocity times A, and then put in our V squared, velocity squared. Okay, so that VA has come from here, what we did earlier. And then, finally, this is a long old question, isn't it? All right, so we've got rho. Now we can simplify because we've got V times V squared. So we've got rho A V squared, V cubed, sorry. Rho A V cubed, V times V squared is V cubed. Okay, so kinetic energy per second equals that. And as we know from our previous lesson or the one before, energy per second is power. So that's the power of a wind turbine. Interesting, I think, because look at that. If you double the wind speed, double the velocity of the wind, that's 2 times 2 times 2. That's 8 times more power. 8 times more power. 8 is a lot just for doubling the wind speed. Even if you increase the wind speed slightly, it's going to have a big effect on the power. That's why placing wind turbines in windy areas is not just important, it's important cubed, as we can say. That's just one example of these questions, but I think it's the trickiest one, and it does come up in quite a few things. Sorry, it's a bit blurred here, not sure why. See you later.